It's all right.
We won't beat you up publicly.
Okay. Save that for public.
All right, we'll let other people do that.
Oh, fair enough. Film it alone.
Thank you, Russ. I got to look really bad.
Interesting for stories that came. Maybe it's an IE thing.
Sheets from the maps, so when we're done, I'll take these and make them better.
Yeah, this is weird. I'm getting a completely different. Yeah, but now it's the same there. That's weird. You said you got in fine.
I didn't find it. I verified that I could hit it. I just used the agenda in there to make sure it's actually there. Okay.
So good morning. This is software updates for Internet of Things, SUIT, working group. So this is the note well. I'm sure you've seen this many times this week.
Follow it anyway.
Indeed. Actually, this doesn't seem to do. Never. So this morning we have a JavaScribe. Thank you, Ludwig. We need 2 note takers. Any volunteers? We'll wait.
Stuart's really good at note taking.
That's one. Thank you, Stuart.
Thank you.
And your name? Robert. Thank you. Yeah, if you could use the Etherpad, that would make things easier. So this is our agenda for today. Any agenda bashing? So working group status. So far we've adopted the architecture and information model drafts as working group drafts. Yeah. We've also received a liaison statement from the IETF SG17, which we'll be talking about in a little bit. They're working on a document describing usage scenarios around software updates. They've shared a draft document with us that's posted out on the data tracker, and they're seeking comments on that draft as well as alignment with the work that we're doing here in the working group. Their next meeting is in August, so if we're going to provide comments, we're going to have to provide those by then. We had a hackathon project at this IETF, and that went well. We'll be hearing a little bit more about that as well later on. So milestone-wise, we've closed out quite a few of our milestones, but we have a few that are a little bit delinquent. My hope is that maybe we can make some progress on those today. So we'll be talking more about the manifest format a little bit later, as well as the information model. So we should definitely make a concerted effort to try to catch up on these milestones soon. And that's it for the status. Any questions? All right, so first up on the agenda is the liaison statement. Can we full screen this?
Click present. First click present here. Yep.
Ah, I see.
Yeah.
And I guess you guys can.
Sure.
Secret slide.
Okay, so I'm going to provide a quick update on the liaison statement that we received. Next slide, please. So the document that the IETF is working on doesn't define specific protocols or formats. They've noted in this document that that we are working on a format for a manifest, and there's an interest in referencing and leveraging the work that we're doing. It's It talks about some of the prior work that has occurred within the IETF and elsewhere on this topic. So basically what the document does is it defines some basic requirements for some of the key architectural roles that participate in the software update process. This is mostly consistent with our architecture. Doing a deeper read of the document, though, I think there is some ambiguity over the function of status trackers, especially with relating to delegation. I'll talk a little bit about that more. Clause 8.1 in the document requires that an IoT device has a status tracker, which is slightly different than our thinking about the topic. Next slide, please. So generally, the way they're defining a software update is starting on the right-hand side. You have an author who creates a firmware image. They publish that image to a firmware server. Starting on the left-hand side, you have a status tracker that is responsible for tracking the current update status of the consumer, and then initiating a firmware update when an update is needed. It instructs the firmware consumer to perform that update. The consumer then requests the firmware from the firmware server, providing the image back to the consumer, either embedded or by downloading. The consumer can then verify and install the firmware and report the updated status to the status tracker. Next slide, please. So the draft talks a little bit about a number of different implementation scenarios for how status trackers are leveraged. So there's an idea that a status tracker can be embedded within the device and communicate directly with the firmware consumer. You can have a status tracker that's responsible within a device for orchestrating multiple consumers. And you can also have, which is indicated on the right, a hierarchical set of status trackers, which is somewhat aligned with our architecture, except that this document does state that that a device needs a status tracker because that status tracker has to be responsible for initiating the firmware update procedure to verify that trigger has occurred and to check the status that the firmware consumer has actually installed the update. So I think there's an opportunity for us to provide some feedback just to seek some clarification there. Some of their examples, next slide please, do seem to indicate that there are devices that might not have a status tracker, but it's not clear, like in the example of devices B and C, whether there's a status tracker implied in this diagram or whether there's actually a status tracker present on that device. I talked with Taki Takahashi, who is one of the authors of this draft, and he would definitely appreciate some feedback on where he can clarify things to make sure that this is in sync with our work. Next slide, please.
I'll mention that Tak has been active in this working group and was at the hackathon,
right.
but he had to leave last night, and so otherwise he might be presenting this now.
That's right. So in the latest revision of the document, there's been a bunch of minor editorial changes, a lot of fixing of case and abbreviations throughout the document. There were a bunch of definitions in the previous version that were kind of inlined with the text. There's a new section, clause 3.2, where all the definitions are now kept. So they're a little bit easier to find in the document. And also they've recently added an appendix 2, which provides an example scenario of IoT software updating using a distributed ledger technology. Next slide, please. So on the distributed ledger technology, it seems like that approach is a little under-specified in the document, so it's not really clear the exact role that a distributed ledger is serving in the update process. So I think there's probably some more work to do for them on that front. So considering this liaison statement, I have a few questions. Is there a need for us to respond? They've stated that there's a desire to have ongoing collaboration with the suite working group. They've been sharing this work. Do we feel like there's a need for us to provide input?
This is Hannes. Yeah, I was just wondering about the earlier mentioned status tracker discussion, because when I provided the text in the architecture document there, the status tracker had somewhat a different semantic, and it was really like a device management functionality.
Right.
And as the name indicates, it monitors the whole firmware update process and wasn't actually on the device itself. So given that there are these subtle changes throughout the time, I'm curious on, like, if they seem to still work on the document, and so I prefer, as I will later explain, I prefer to wrap up with the architecture document at some point in time in the near future, and then there may be some, the two documents may drift apart, so I don't know what their roadmap is, or whether they are now freezing their architecture, what the story there is.
No, I think they're still working on the document and plan to at least continue to do so through August. Interesting enough, I looked at the previous version of the document, and this discrepancy is actually present in the previous version as well. So there doesn't seem to be a lot of progress yet on clarifying these points. Maybe that's because we haven't provided enough feedback to them.
As the person taking notes, I'm going to remind everybody at the microphone, please state your name, because if you don't say your name, you don't go in the notes, and then it's as if you never said it.
So starting from stating my name, Vasily Dolmatov Kryptonit, I would like to mark my presence here just as a possible point of contact with Study Group 17, being a vice chairman of Study Group 17. I would like to point out another point of contact you maybe have seen Arno today, who is working party chairman of Study Group 17. And in the absence of Takeshi Takahashi, we can provide a contact and collaboration. Thank you.
Thank you.
This is Brendan Moran at the mic. I've gone through this document, and there are a number of points of ambiguity that I think we would need to resolve before we could move forward with more alignment between our two groups. In particular, the status tracker needs significantly more definition. The status tracker is currently defined as doing a great many things. In fact, I think that you could probably construct an update system entirely out of status trackers. I think that it needs perhaps a bit more definition and perhaps a bit more division between different roles.
Yeah, and actually I think different roles for status trackers, because it's not clear what the difference in function is between a delegating status tracker and sort of a delegated to status tracker.
Yeah, I mean, I even saw a line in there that said a status tracker may reside inside a status tracker.
Right. It's turtles the whole way down.
So just an observation on the first question of, do we need to respond? This isn't the first time that we've asked that question. It's obviously not the first time we've got a liaison from Study Group 17. So far, the way that it has worked in the other direction, so by the way, in this direction, my understanding, I am not an IETF Study Group 17 expert, but my understanding is the mechanism that they have to share the document with us is through a liaison statement. And so that's why we get liaison statements from them, so that we can review the document. And the other direction, we don't need a liaison statement for them to review our documents. And so in the other direction, it's been working by email to TAC and discussion on our public list. And so do we need to respond is not the same question as do we need to send a liaison, right? It may be discussed on the list to which TAC and Vasily or whatever are visible participants in. And so that may be sufficient.
Yeah.
Brendan, if you have comments, just posting them to the list and making sure that TAC sees them may be sufficient rather than going through the formal liaison process. We can send a liaison if we feel a need to. but so far we have not felt a need to.
Juan Carlos Zúñiga. Well, actually, not specifically for ITU, but other standard organizations tend to be like IEEE, 3GPP, and so tend to be much more formal in their communication. So indeed, sometimes they expect a liaison response.
I see the person behind you with the mic may have advice for us.
Okay, thanks. So I would suggest indeed conveying this information, well, at least capturing it. It's already a good start. I think the questions that Brendan asked are fairly good. And maybe we can ask Takeshi what would be the best way to communicate back so that the message gets through with the group. That would be my suggestion.
Thank you. A bit of clarification. Again, I was a little matter. A bit of clarification on ITUT procedures and the liaison statements. You correctly stated the role of liaison statements in the ITU. So, which way I would propose? If someone wants to work on the text and the contents of the document, it's better. Most efficient way to contact Takeshi Takahashi directly and work through with him, maybe participate as a co-editor or something like that. Liaison statements you will need in two situations. First one, if the ITUT does something definitely wrong in your perception, then studying liaison to ITUT can definitely stop the process and start rethinking and discussion. Another way which I prefer, if you definitely support this, you can send liaison statement saying that you support this document and its contents, and it will speed up the recommendation approval. Thank you.
Thank you.
One quick clarifying question, if you don't mind. So if someone was seeking to actually help author this document, do they have to be a member of SG 17 in order to contribute, or is there a way to do that with an outside party?
An official way is to make a contribution from a member state. I do not think that's quite a way to do that. No restrictions to the participations is imposed on them.
Okay.
Maybe if one like to hear his name as a co-author of the document, he should represent either member states or sector member, which are a lot of large companies are. So that depends on the position of the person and its wishes. That doesn't prevent any meaningful work with the document, with the editors of the document.
Okay. Okay, so on another point, I was talking with Takeshi earlier in the week, and he expressed a desire to have someone else help with editing this document. So if there's a member of this group that would be willing to contribute some time, he would welcome that contribution pending what we were just talking about. I think that the person that would be helping would probably have to be a representative then of a member state in order to or a sector member in order to contribute. So if there are any parties interested in participating, please email Takeshi about your interest. That's it.
Hello, just gonna give a small status report on what we did at the hackathon. Next slide, please. Next slide. So here's the team. We're 12 people, one remote. Yeah, really nice. Next slide, please. So as you know, here we're working on software updates for IoT. So we are working on architecture and metadata for software updates. It's actually firmware updates now for IoT devices, including small microcontrollers, not to forget them. At a hackathon, we worked on hands-on implementation of the latest metadata format draft. So it's the CBOR manifest format, draft more on 04. Next slide. So what happened at hackathon? At the hackathon, we had available new manifest generators, 2 of them, one from ARM and one from Renesas. We had new manifest parsers, 3 independent implementations, and one from INRIA, one from ARM, one from Renesas, and 2 of these implementations were actually running on actual hardware, on actually small microcontrollers. So one with 32 kilobits of RAM, and the other with 64 kilobits of RAM. So we're pretty in a, let's say, the low end here, and we're happy to see that. We could demonstrate interoperability between the manifest generator from ARM and the parsers from INRIA and Freie Universität on one hand, and the parser from Renesas. So that's good. And we also had a full workflow demo of firmware building, manifest building, and transporting that to a Riot device, and actually doing a firmware update with that thing. Yeah, next slide. So what did we learn? There were a couple of aspects in the spec where there were several ways to do things and cause confusions. It's not the first time it happens in the IETF, but you know, so the similar conclusion is that we should just define one way to do things. Maybe Brendan will talk about that a little bit later. And first and foremost, IETF Hackathon is fun and really nice venue to make some progress. So for those who weren't there, please consider coming next time. Yeah, next slide. Yeah, so for more information, we had an Etherpad where we noted a bunch of things and links, useful links for what happened at the hackathon concerning Suit. Yeah, and then the usual links to the spec work in progress and the working group. That's it.
Yeah, thank you. Thank you for all your efforts at the hackathon. I think it's architecture.
Yeah, architecture first.
So I think next we're going to talk about architecture. Hannes, you want us to bring up the draft?
We don't already have that one open, sorry. New tab. You want the actual document, correct? Okay.
It is quite short, so I didn't put some slides together. So I submitted 2 draft updates since the last IETF meeting. The first one was early this year to do a terminology alignment that was discussed at the last IETF meeting in context of what we discussed earlier with the ITOT liaison and that document. So it seems that there may be some additional work. And for the second update, I added some text on bootloaders, specifically following the discussion that we saw on the list where the focus of the firmware update didn't just include sort of the transfer of the firmware plus the manifest from some devices, from the firmware also all the way to the IoT device, but also then concerned the question of what happens then afterwards at the device, and specifically the interaction with secure boot. And so we've seen that some people want to use the same manifest, or at least the stripped down version, for the secure boot mechanism afterwards. And I tried to capture that discussion a little bit in there. I tried to keep it as short as possible because there are obviously a number of ways to design a bootloader with different stages, and we talked about this in previous meetings before when I spoke about the hackathon. So there are different design choices, and I didn't want to preclude or favor one specific approach. But there will obviously be implications in terms of code reuse and the security property of the device itself, depending on what you're doing. But this was clearly something that seems to be important to people, because they want to reuse a format, don't want to use a specialized format, and again for the metadata that is used by the bootloader, when itself it has to verify the firmware that's on the device. So it's a similar task, and the information model document and also the solution document took that into account by offering fields that can be stripped off later in the process, because clearly there's some information that is more relevant for the transit and the initial verification at the device rather than during the boot process. So that's something I included. Dave sent a message earlier this week, actually Monday, with a note from Dave Wheeler, which wanted to have additional clarification regarding the trust anchor, which currently only talks about it being a public key, but also wanted to highlight that there are some requirements regarding the protection of those keys. Clearly, you can't just store it in Flash and let everyone modify it. So there are some requirements to protect it against modification, against stripping it out, deleting it, etc., etc. So I'm going to add that. I think that's a minor clarification, but still quite useful, a useful addition. And otherwise, I would suggest to. I would have suggested to start a working group last call, but now I'm not quite sure anymore with the discussions about the status tracker and some of the other IDOT work. So I'm not entirely sure, but.
Yeah, it seems like that could happen in parallel with the working group last call.
Okay.
I mean, we are a little behind on our milestone there,
Yeah.
so it would be useful to move things forward. So I'm interested in maybe raise of hands. How many people have read this draft? Maybe 10?
At least 15.
15?
Yeah.
That's a good number.
15, give or take.
Does anyone have any concerns with moving this forward after this one revision is made?
Moving it forward, meaning starting working group last call.
Okay, so Hannes, when do you think you could ship an update to the draft?
With this small addition?
Yeah.
I can do that today. I can do it when I sit down.
Well, that's perfect. So
Yeah.
so maybe later today we can actually start the working group last call. Thank
Okay.
you.
Now we start the running there now.
This is where I'm supposed to stand, right?
Right over
Yeah.
the trap door, yeah.
Yeah, right over the trapdoor. Okay, good.
Yeah, if you could stand on the X.
Okay, so following IETF 103, there were a number of updates requested to the information model. Specifically, these had to do with a couple of new threats and one new threat and a couple of new use cases. Next slide, please. So what's happened mostly in this update is that we've rearranged elements mostly to place the manifest elements at the beginning. That was on request of the chairs at the previous IETF. And then, as I said, new threats and new use cases. Next slide, please. So HRPC requested that we address the possibility of exposing information about an individual by exposing what devices they have. And so that requires obfuscating the contents of a manifest, because even though it doesn't contain any IP, it could contain device identifying information, and that could reveal information about a person or the things they own. So to resolve that, we've added a new security requirement for the option of having encrypted manifests. Next slide, please. There were several new use cases discussed, specifically, as Hannes mentioned, secure boot. And once secure boot was an option, the next thing to add in was the ability to transform a firmware image during the loading process. So decompress on load was the use case that was given to me, but I'm quite certain that decrypt on load is also a requirement. So that's been added in as well. And there was significant discussion on the mailing list about simple parsing. So we've added that as a required use case in the information model. Next slide, please. And from that, we derived 4 almost identical usability requirements. And that's about it for updates to the information model. Yeah, that's the last one, isn't it?
So do we think that this one is also ready for working group last call? First of all, to the author, are there any outstanding comments that you know of on this document that have not already been addressed to your belief?
I think there are a few outstanding comments, yes. They are largely editorial in nature.
Okay.
Any non-editorial?
Yeah.
I'm not aware of any technical comments, no.
Okay.
Dave Wheeler. So I haven't read all of the documents in detail, but I did spend a couple hours yesterday reading through the information model and things, specifically with the purpose of trying to reuse the manifests for TEEP. And I think there may be some things that we might want to add to this, but I don't have anything right now solid to give you as input. But I should do that within the next couple of weeks. So since you're asking about last call, I just wanted to let you know we're considering using the manifest for TEEP, and I think we will have a few things that we'd like to add to it.
Yeah, we'd absolutely like to get input from TEEP. I think it's important for us to get alignment between these 2 working groups.
Okay, thanks.
Chair conference.
So we were just considering maybe doing a 4-week working group last call on this version of the document, which would then allow for some time for additional comments on the draft to be considered. And then based on those comments, we can go from there. Any concerns with that approach?
Brendan, you said there were some editorial comments. Do you have any timeline on when you are planning to address the editorial comments?
Hopefully this week.
Okay, so if they can be addressed by Friday, then we can say we're just going to start the work. We're going to send out the working group last call as soon as that appears. If it's going to be longer than that, then we should go ahead and start it. But if you're going to potentially do it before Friday, then we'll send out the working group last call announcements initiation on Friday. If that's sounds good. Yeah. So if we can get done by Friday, great.
Yeah. All right.
All right, great. Thank you. Anything else?
I think the next one is also me.
Yeah, we're on the Brendan marathon now.
The next 2.
All right, so this has been a major revision from the previous draft. Next slide, please. So I really want to thank everyone who's contributed. I've gotten a lot of feedback, not all of it positive, on the previous draft, and that encouraged me to do a major rethink of the mechanism that we were using to handle the serialization of the information model. And the rethink, I think it produces a much simpler result. The format ends up being, the format is constructed specifically to make the parser simple. That doesn't mean in all cases that it makes the format smaller, but it doesn't increase it significantly, I don't think. I'll have to, I've had some discussions about every byte counts, but it's still, I think that the trade-offs are in the right vein. Next slide, please. So this is just an overview of what we're going to, or what I'm going to talk to you about. Let's get into the reasoning behind the changes. So the previous draft was very complex, and every time I added a new use case, it got more complex. And that means complex parsers, and that means complex code, and that means more space on constrained devices. I didn't like where this was going. So the new use cases were introducing new optional fields in places that already had significant numbers of optional fields. This also made capability reporting really complicated, and the irregular structure of the data made it very difficult to parse efficiently. Next slide, please. So there are a few different things that are turning up in this draft, and the important ones to recognize are commands, which are either the instruction to a device to test something, or the instruction to a device to do something. There are parameters which the devices use in order to perform those two operations, and the components are the things that devices operate on. Those are typically firmware images or other resources that a device uses. Next slide, please. So at the high level, the only real change is that I've moved the authentication container, typically COSI, into a B string. Or I guess we're saying it is COSI. So the COSI container goes into a B string. Now that is specifically to ensure that the top level parser doesn't require a understanding of COSI. This is to partition the responsibility for understanding different formats into the individual software modules that implement them. I've also expanded the CDDL that describes the authentication container to allow an array of authentication methods. This was because it allowed us to handle both a COSI MAC and a COSI signature within the same block, which would otherwise not be possible. The manifest itself has substantial changes, which we'll get into in a moment here. Next, please. All right, so the new manifest is divided into two major sections. There's the common data area. Now the first two elements in that are different from the rest. Those two elements are specifically intended for an external system or external software to be able to read. It's not really part of what the manifest processor handles. This is because the structure version informs a device whether or not its manifest processor can handle the data, and the second allows it to decide which manifest it should be looking at. So both of these things have to happen before a device is able to actually start processing its manifest. This is again a secure boot question rather than a update question. You need to know the sequence number before you can pick which partition to boot. Then there are dependencies and affected components. So those are components that are affected by the manifest or its dependencies. The dependencies are other manifests that are required by the one that's being processed. Behavior definitions are used to explain to a device exactly what it's supposed to be doing in the course of an update or a secure boot process. And as Karsten has pointed out, they are effectively scripts. But I didn't want to use the term scripts because I don't, scripts have a lot of baggage. And one thing you don't want in a secure boot process is a lot of baggage. So this is, the reason I'm saying behavior definitions rather than something else is because we've removed the possibility to do some of the things that scripts do that make them problematic in this kind of space. Specifically the ability to perform branches and loops there is no halting problem here. The complexity is sort of enforced to be low. So the two steps that are laid out here, the install and the run, are broken down into 3 pieces each. I'd like feedback on whether these are the correct 3 pieces. I believe they are, but there may be other requirements out there. I think that they should be relatively self-explanatory. Next slide, please. So all commands must target a component. This is because components are essentially what we're operating on. If it's not targeting a component, then it really doesn't do anything on a device. Some commands may target all components. This is an optimization to allow you to say, go and fetch all of the components that are about to be installed, or do an image verification on everything. Most parameters are scoped by component. There are 2 specific parameters that are not scoped by component, but I'll talk about those a bit later. Next, please. Commands are either conditions or directives, as I mentioned. The commands typically consume parameters instead of arguments. There are a few exceptions to this. For example, the vendor ID and class ID can take an argument rather than a parameter. This is perhaps an instance of 2 ways to do things, and we might want to consider removing that. But given that I can't see a reason for a device to make a decision about what class it is or what vendor it is, I think that it might make sense to say that these cannot be parameters and they must be arguments. So some commands consume arguments where only a single use is expected, which is the vendor ID, class ID kind of scenario, and override is not expected to be needed. And I'll talk a little bit more about what override is in a few slides. Next, please. So there are behavior definitions. Command lists are composed of 2 different components, the conditions and directives. The conditions are for ensuring applicability, ensuring correctness, ensuring that and allowing a device to make a decision about what it's going to do. And that's implemented through the sub-behavior directive, which essentially allows a device to have a soft failure on a condition check, which is the way that we implement conditionals in the manifest. It's done in that way because it allows reuse of the same command sequence parser as the existing one. And I have been assured by at least one person who was at the hackathon that it was trivial to implement that way. Yes, next slide, please. So the parameters that don't require a component to act on are the strict order and soft failure parameters. So the soft failure parameter is the one that enables conditionals that, as I just described. Strict order is a parameter you will only ever see on a device with many components and lots of RAM. This is a mechanism to allow it to do things out of order where they do not have dependencies. This is for one particular use case, at least, that I've seen, where a Linux device wants full say over how it installs things and in which order it installs them. And to enable that, the manifest as it exists today would make that explicitly impossible. So the strict order flag, if strict order is disabled, will allow the device to collect all of the commands until strict order is turned on again, and then execute them in whatever order it feels like. The remainder are the list of sources. So those are URIs typically in download, but for boot and loading, those will be component IDs. Processing step configuration. So these are things like decompression, decryption, and unpacking. And image identifiers are typically cryptographic digests of an image, but I also allow for the possibility, due to previous requests from this group, that they could be version numbers. there may be an interface version that's required, and verifying that an interface version is available is the domain of the manifest in this particular type of parameter. And finally, device identity, which we've defined under the UUID scheme that's described in the document. Next, please. So I'm going to go through an example to just show how this fits together, and then we'll talk about sizes for a few more examples after I've gotten through here. So here's the information that will encode into a manifest in the current format. It's about 96 bytes of information, but what's not obvious here is that there are also instructions to a device on how to use that information. So this is just the raw information. If you were doing this bespoke, the minimum that you could use to encode this information is 96 bytes, since that's exactly what the data size is. We could encode it in 169 bytes. But that does give the device some flexibility on how to use it. Next slide, please. So the outer wrapper is the same as it always was. It's not terribly exciting. Next slide, please. The inner part of the manifest shows the version number, the sequence number. It's got one payload. I will talk a little bit more at the end on the open issues about how the component is listed there. I think we can do better. Then we've got the common section. The common is executed before every other command list. And then validate. So this is just doing secure boot, no, apply and then validate. There we are. Apply, validate, and run. So common is executed before each of these others, and that's to enable essentially size reduction, because it contains the digest, as I'll show you in a moment. It reduces the amount of space that's consumed because the digest doesn't have to be repeated in each segment. Next, please. So in here, it sets the component index to 0, checks the IDs, and sets up the digest that will be expected later, and the size that will be expected later. Next, please. Oh, my highlighting's all gone. Can't see which section you're in. Okay. So this section is apply, and in apply, what is happening is that it's doing a simultaneous fetch and install. There are two separate sections for fetch and install, but on very constrained devices, we expect them to do fetching and installing simultaneously. So because of that, the fetch section ends up also in the apply section. So it's a bstring wrapped URI list that's configured as the second parameter. Now the second parameter is, I think it's another area where we can have some improvement. There was some comments during the hackathon as well that this is not this particular format, this encoding is difficult to parse, and I think that we should try and find a better solution for that, and I've got some more information on that in the open issues section. The last element there, 20, is a fetch all elements directive, but it's evidently not in the description. Okay, next slide, please. Here it's very simple. This is apply, or this is validate. So this is a very simple section. It just sets the component index and validates the now downloaded image against the component that it's got specified by the component index. Next, please. And here's run. It's same thing again, component index, and run the selected component. Now this, I hope that it's obvious that we're setting the component index a lot and possibly too much. And so one of the other open issues is, should we have a default for that so that it's not necessary to set a component index all the time? Next, please. Something got dropped there. I don't know why we ended up with, what was that, 2 6s, or we're missing 7. So all of the manifest sizes that I'll give in the next section are done without the cozy authentication structure. I hope Jim will correct me if I'm wrong here, but those sizes, I believe, are roughly correct, barring large key IDs, of course. So you can add those numbers for authentication depending on what your use case is. Next, please. So a pure secure boot manifest encodes 47 bytes of information and consumes 91 bytes encoded. Again, dependent on exactly what your component ID is. Next slide, please. For a minimal update without secure boot, again, depending on your component ID and your URI, 74 bytes of information encoded in 130 bytes of manifest. Next, please. Adding boot to that costs you 9 bytes. Next, please. So now adding compatibility or applicability, rather, verification to this, it's an additional 32 bytes worth of UUIDs, and it ends up being encoded in 177 bytes. Next, please. So the parser that I've put together to verify this took me about 600 lines of C for the part that executes the manifest, and about 200 lines of C for simple CBOR information and extraction. That isn't compiled sizes, obviously, and the C is pretty vanilla and probably has too many prints in it. So that's just a ballpark figure for how complex it is to implement. And I'd love to get feedback from anyone else who's had a go at implementing it, if that's available, or if someone's on the line perhaps who could mention that when we're done here. Next, please. So there are a few open issues. As has been pointed out already, there are a few places where there's more than one way to do things, and that makes parsers more complex, so we should get rid of them. The digest and size pair was done as a mechanism to trade off between parser complexity and data size. So encoding it the way in one way would produce a smaller manifest but a more complex parser, and encoding it the other way would produce a less complex parser but a larger manifest. I think that since one of the mechanisms is required for a few use cases and the other is not explicitly required for any other than the size optimization, I think that we should stick with the slightly larger but less complex method. The URI list is complex. I don't like how much parsing it takes to handle it, and I'm not convinced that there are a lot of use cases that require the URI list that we have at the moment. I think there are 3 different ways that we could deal with it. So we've got the existing one, which is effectively a multi-map, just not listed that way. I think that we could, I don't think it's necessary. So the second option is just a plain list of URIs, where priority comes out of the order in the map or in the list, rather than coming out of an explicit priority number listed with the URI. The second possibility is a map of URIs keyed by priority that prevents duplicate priorities. That's the only problem that it has, I think. So what these options don't enable, because that apparently has cut off. It's like I forgot to save it at some point. So what these don't enable is the ability to have multiple URIs at the same priority. That was raised as a possible optimization at one point, where devices need to choose among multiple URIs at the same priority for geographic region selection, for example. I think that this is a fairly complex use case. And in situations like that, I think devices should probably work out their own priorities based on order and based on geographic region. And I think that having an explicit priority in there is probably not something that's beneficial to most devices. So I think either a list or a map is probably the right answer. Command encoding, it also has a bit of an open issue. Right now, it's an array of maps. An array of maps is fine. It's equivalent to an array of arrays with 2 elements each. So there's no semantic difference there. I think the array of maps is probably okay. a multi-map would be a more efficient encoding, but I gather that CBOR has considered this and rejected it numerous times. So the other option that's been brought up is a pseudo multi-map. I call it that because that's the best explanation I can have for it, where we alternate keys and values in each successive element. I think that the array of maps is probably fine. It adds a few bytes, but it makes the semantics a lot easier to follow. So we also have the issue I raised a few minutes ago about the default component and dependency index. It was fairly obvious going through that example that the component index gets set repetitively. I think that that probably means that we need to have a default because that's extra encoding that we don't need every time. And finally, I've had a request for scriptless operation, as in a mechanism to put this manifest together without having any of the command sections present. This would be fine, except that if we remove the ability to lay out the digest and size of a payload in its component description and move that explicitly into the command sequence, we won't be able to do that. So there's a trade-off here where you could use this manifest in a completely scriptless way. But if we eliminate one of the ways of doing digests and sizes, we'll lose that ability. So I'd like feedback from the group on how we should handle that. And I think that's it. Is there another one? No, that's it.
That's a lot.
Comments? Take an issue. What do you insist?
So one comment on the
David
URI.
Wheeler.
I'm sorry, Dave Wheeler. One comment on the URI list. In TEEP, when we look for the source for an element that we're going to download, there are an equal number. All of the options are equally valid, but a device may choose one based upon their trust anchor list. And so the URI has to include both where to go get it and the key. And one of the things that we've been talking about is that particular URI might need to be signed to prove that it's valid. So I want to maybe explore that with you some more via email if we're thinking about this in the right way. But it creates a rather complex case, I think, for the URI list.
Yeah, it's also possible that we could handle that one through another command. One of the benefits of this approach is that if there's a complex use case that not all devices are going to need to handle, we can actually just add a new command to enable that.
Okay, that sounds like a good idea. So I'll talk to you over email.
Okay. I think this would actually be a good point to raise capability reporting under this model. Capability reporting is dramatically simplified from previous models because all a device needs to do is report which component IDs it has, which commands it supports, and which parameters it supports. If it can report those three things, then any remote system can tell exactly what the device is capable of in 3 lists, which is dramatically easier than it was in the previous drafts, where capability reporting had absolutely nothing to do with the draft, and it was a completely separate topic that needed to be addressed.
Manuel Bocelli, INRIA. So we've got 2 of the implementers that are online in Mythico. I don't know if they will speak up or if they are in a position to speak up. But from our initial measurements of our implementation, which is not complete, so maybe Kun is going to say some more later. We see an impact on code size compared to V1 against preliminary results. It's quite substantial, but depending on how much flash we have on the device, it's still like relatively to the flash, like you have to relate that to the number, the amount of flash we have. So when I hear that we may want to run this stuff in the T, where we might have like, I don't know, like reduced amount of flash, this might become like something we want to characterize at some point. I don't know if Kuhn wants to say something. It seems he came to the mic, so maybe I'll let him talk about this.
So we'll go. Please go ahead. Sounds like
That's perfect for a ghost. Yes.
Okay, I'll
actually yeah, unfortunately we're having audio issues, so we'll have to mute you.
So just to give some quick numbers, like for V1 we were about like 600 bytes of code size, and here we're about, if I remember correctly, triple that. But okay, so if you're thinking about like a device with 128 kilobytes of flash, that's like bearable. If you're thinking about like 64 or 3 kilobytes of flash in a really small T, then maybe it's like it becomes like something significant to take into account. But again, like these are very preliminary results I just got now, so to be confirmed. This is based on our hackathon hacking whatever. So maybe we can.
Some optimization possible, maybe?
Maybe, yeah. So.
So at this point, another comment at the mic. Please go ahead.
Not quite. Kuhn is typing. 1 second.
Okay. I think he just finished.
No. Ludwig Seitz for the Jabber Room, Cohen. A clarification on the cozy handling would be nice to have. Maybe some examples what exactly should be passed to the signature verification.
Yes, I raised that yesterday in the COSI working group.
So at this point, it seems like most of the comments have been positive and constructive about improving the existing format. We had some previous commentary about other manifest formats, but those have seemed to be mostly addressed at this point. So are there any concerns in the room around moving forward with adopting this as the manifest format? So not seeing any objections, we will confirm adopting this document on the list, and we'll have you move forward with posting this as a working group draft.
Oh, looks like we have another comment.
Ludwig Seitz relaying a Jabber comment from Kaspar Schleiser. The smallest MCUs need simpler, I don't know what's simpler. Simpler manifests. 32 kilobyte MCU with flash split in half cannot spend 2 to 4 kilobytes on CBOR and manifest parsing.
I agree. And I think if you look through the mailing list archive, there was a point I raised some time ago about not using CBOR parsers to parse CBOR. There's a way of just doing exact matching, with memcompare that you can take as an approach to really cut down size if you're in a very fixed function case like that.
which case it looks a lot like a binary structure, right? If
Yeah,
you're just doing
exactly.
exactly that, right?
That's right. If you make a consistently structured CBOR object, you can treat it as a binary structure.
Okay, thank you. So I think we'll move on to,
Before we move on, where are the blue sheets? Is a blue sheet near you? Raise it up so we can see where they are. I want to make sure. Are there people in the room that have not seen the blue sheets? Go by them. Please send the blue sheets in those directions if you see a blue sheet. Thank you.
I think there's one more, isn't there?
yes, there is.
Yeah, there is.
So this is a quick overview of the work that went into the creation of Manifest 04. It's essentially the information model, if you will, behind the serialization of the command sequences. And it goes a little bit into the ideas that we used to generate that serialization and the reasons behind them. So what does a recipient do when it needs to do an update? Probably check for authenticity, assuming it's not guaranteed by some other means. And then it needs to install a payload, but there are a number of questions around that as well. Next, please. So descriptive updates, binary formats, provide a recipient with explicit information in a number of different ways, and then expect the recipient to act on that information via some pre-agreed methodology. Next, please. It's got a few pros. It can be quite compact, and it's easy to present to a user, but it doesn't specify behavior very well. And that means particularly that you end up with a lot of corner cases, and that all of the understanding of how to use that information winds up in the code rather than in the manifest itself. The data is complex, and that makes parsers complex. When you have structures that repeat, you either end up with a general purpose parser, in which case you have to understand the structure that it outputs, or you end up with a complex fixed function parser, which has to, again, understand the structure that it's parsing. And capability reporting, as I mentioned earlier, is it's a completely separate definition, and it's a separate problem. Next, please. The other option is to specify things in a behavioral way, to specify exactly what a device should do, instructing it on how to perform each step in a normal update process and in a secure root process, as the recent use cases have pointed out. The same information is all there, but the organization is different. Next, please. So it's unambiguous as to what a device should do because it's constructed of directions to a device. The data encoding is very simple. The parsing should be very simple, although those numbers that Emmanuel has been giving me are concerning. The behavior is explicit, not implied, which is beneficial from a security perspective, and there's a high degree of flexibility. The code size, the size of the manifest itself may be larger, but that's an encoding question rather than an informational question. And there's more tooling required, definitely, because it effectively turns your manifest generation infrastructure into what is effectively a compiler. It also means that presenting the information in a manifest to a user requires tooling as well. Next, please. The outer structure is the same as I've shown in the previous set of slides. You have the authentication wrapper and then a set of externally accessible data, which is used by other parts of the system, then common data that's shared between all of the operations performed on the device, and then finally the command lists that the device uses to process through the manifest. Next, please. So we constructed 6 command lists and one common command list that gets executed before each of the others. This was done to ensure that each of the phases that a device typically goes through in an update would be catered for. Next, please. Dependency handling is something that needs special attention in this model. It's explicit, as all of the other operations on the device are, but because dependencies have to be resolved, all of them, before any one dependency is processed in any other way, the command lists have to be handled in lockstep. So dependency resolution of the first manifest has to complete, or at least partially complete, before, no, the dependency resolution has to complete before the image acquisition starts. Now, that's important because you want to have early failure in devices. You want to know that an update will be able to acquire all of its dependencies before you start applying the update. Likewise, you want to know that a device will be able to acquire all of its images before it starts to install any one image. Similarly, on the secure boot side, you need to do all of your system verification before you load any image. So that's the reasoning between dividing out these command lists into their component parts. When dependencies are involved, we need to be able to divide down into the individual substeps of the update process. And dependencies are explicitly processed. So there's a command in the manifest to say, go and process a dependency. And that means that it processes the current command list in the next dependency. So dependency resolution means dependency resolution. Image acquisition means image acquisition, and so on. Next, please. I've gone through the lists of commands. There's one here that wasn't listed in the other one, which is the third-party authorization, and on the other side, the directive, which is wait for an event. Those are two cases that we have found will probably be needed in a lot of devices. Next, please. I've talked about the different parameters already. I don't think that I need to go through that again. Next, please. Oh, that's it. Okay, there you are. So that's just an overview of the process that we went to get here. It's very similar, I guess.
Questions or comments?
And for reference, this was purely informational. I think that the content in it should mostly be rolled into the manifest serialization so that it's a standalone document.
Any concerns with taking that approach?
Oh, so we're running early.
Ludwig Seitz, relaying comment from David Brown on the Jabber. So dependencies seem to be restricted to specific version, not something like semantic versions? Question.
Currently, dependencies are managed by digest. That's because you depend on a specific manifest. If that's not going to be the case, then it's going to be much more difficult to construct a secure dependency chain. The other mechanism for handling this is to verify, to check for availability of a particular version. And we already do have that, but it's not constructed as a dependency.
So I guess for the next update, you can merge the documents
To be honest, they already are largely merged. Okay. There's a little bit of overflow, and the terminology is slightly different. It's much more generic in the behavioral draft.
Okay. Anything else?
All right.
Yeah, so I think now we can move on to any other business, and then we'll just quickly summarize the actions at the end.
Russ Housley. 2 meetings ago, I advocated that we take a look at hash-based signatures, and I just wanted to provide a update on where the work in the COSE working group has gone to allow us to do that. Since we were aligned with CBOR, we needed signatures there. The hash-based signature specification out of the CFRG is in the RFC editor queue. They're in auth 48, so we actually know what the RFC number is now. It'll appear very shortly. Then the COSE spec is progressing that says how to use that algorithm in the COSE structures. That is ready for working group last call. So I think we now have all the documents fairly mature at a place where if we want to use that algorithm, we have the things we can reference to do so.
So I'll mention, Emmanuel didn't put it into the hackathon report, but at the hackathon there was actually a question that was raised at the suit table, which is, so what is the status of quantum resistant stuff? We've talked about that before, but we didn't hear about that, and that's actually what Russ was just answering, was the question that came up at the hackathon. So Emmanuel, you want to say anything else?
Emmanuel Bocelli. Yeah, here. I was at COSE, so I remember some of your slides, and you were talking about the signature sizes depending on how many times you can sign and etc. And like lasting a long time obviously means longer signatures. Like I remember like you had like the very minimum 30,000 signatures or something like that. With like rather small slides. Is that the type of thing that we would recommend to use for software updates on like really small devices?
Yes, that is, depending on how you actually manage your software development process. Because the thing with hash-based signatures that's different than others is when you create the tree, the number of leaf nodes defines the number of signatures that you can produce. So if you are going to do multiple builds a day, then that's probably not enough. But if you expect, a release once a month, that's plenty. So that's a trade-off that I think each software developer needs to do themselves. They probably don't want to use the same tree for software development as they do for production. Yes.
Brendan Moran here. Is there a profile that would allow me to say use 4 or 16, something small? I mean, if we're
4
talking
or
about
16 what?
signatures only in the lifespan of the signature. Or of
That
the,
sounds really scary, because then when you use the left leaf, you can't do any update without installing a new trust anchor.
Right, but we're in firmware update here. So why can't my last signature be of the next public key?
It could.
So because of that, and because we are very constrained in some use cases
Mhm.
on size, it would seem to me like having the ability to ship small signatures outweighs the requirement to have a lot of repetition.
You can certainly look at that, but right now the specification, I think the smallest tree is like it's 5 levels. Okay, so 2 to the 5 signatures.
32. Okay,
Yeah.
that's a good number. That's a good number to have. Thank you.
Okay.
Thanks, Russ. So we should just quickly summarize what actions. So Hannes, thanks for submitting the update. We issued the working group last call on the architecture. For the information model, We are going to wait on the last update there and then start the 4-week working group last call towards the end of this week. We will confirm the call for adoption on the suit manifest format on the list. Anything else?
That's everything I had. Note taker, anything else we missed?
Okay, so with that, I think we'll wrap up the meeting. Thank you, everyone, and we'll see you next time. Thanks. Awesome. I'll send you a link actually. That's what the film would You can click on that box. Yeah, yeah. The one with the pink thing. Thank you. I was just gonna, if you need to sign the blue sheets, they're up here.
Yeah, we should give an extra week at least because usually we give people a week to decompress before, so maybe it should be 3. We'll see. Well, except when he doesn't have it.
I didn't want it to be April 15th.
People need a week to decompress after that one.